So we've been talking about roots all year. We've just mostly been talking about square roots. Um, on that 5.0 worksheet, you did have some cube roots and fourth roots and fifth roots and whatever. So it's kind of a good thing to revisit the square roots when we're extending it past square roots. The reason 2 is the square root of 4 is because if you square 2, you get 4. Okay, so a square root of a number is a solution to that equation. So it's like, what can I square and get some number? Say 9. Well, it could either have been 3 or -3. So if I say out loud, what's the square root of 9? Then you say it's either 3 or -3. However, if you see it written on a sheet of paper, that's just 3, because this is the principal square root. That's a function. Okay? I know that's confusing, but that's why it's important to say the principal square root, because when you just say out loud square root, technically there's 2 answers. And I'm bad to do that too. And y'all feel free to call me out on when I don't, because I need to get better at it. Okay, cube roots are the same thing. Like, what do you cube to get a number? So while up here it said every positive number has 2 square roots, because if I square either a positive or a negative, I'll get a positive. When you're doing cube roots, like, what can I cube to get -27? Only one thing, -3. What can I cube to get +27? Only one thing, +3. So when you're doing cube roots, the cube root, it's just that one number as long as we're talking about real numbers. Now, in pre-cal, actually, I don't know if you do this in pre-cal here. I always did it back home. But eventually, when you start doing more and more and more with the complex number set with imaginaries and everything else, you'll discover that whatever the root is, there are that many. Like at the fifth root, there will be 5 fifth roots. There will be 7 seventh roots. It's just a lot of them are imaginary. Actually, the majority of them are. So, but if we say that we're talking about just the real ones, like anything with an odd root will have just one answer. But anything with an even root will have 2, because, like, what can you take to the fourth and get 16? Either 2 or -2. So if you say it out loud, what's the fourth root of 16? And it's either +2 or -2. But if you wrote it on a sheet of paper, we have, the principal fourth root, which is only +2. We want there to be only one output. And then I guess we're going to bring this up. Whatever that number is right there, we call that the index. Whatever we're taking the root of, that's called the radicand, because those words will get thrown around a lot. Okay? And so this just kind of summed up what we said. Oh, and then whatever root you're taking of 0 is just 0. So you're good there. All right. So this one says find the cube root or roots of -216. So what do you cube to get -216? Well, I guarantee it's a negative number. And then 216, if you're not quite sure, Oop, 3 and 9, 3 and 3. Cube roots, you're hunting for 3 of something. So 2 times 3 makes 6. So the cube root of -216 is -6. All right, now the fourth roots, what can I take to the fourth power and get 81? Well, it's either positive or negative, the fourth root of 81, which is 3. Okay? But if you see it typed up, that's the principal one. That's just flat out 3. Okay, but when you have problems like this, just like when we were solving them before, you're doing this in your head. So let's divide both sides by 4. What was that, 32? And you're saying, all right, what can I take to the 5th power and get a 32? Well, there's only one thing. It's just a 2, because it's an odd power. There's only going to be the one answer. Okay, if I divide both sides by 5, 64. What can I cube and get 64? Well, there's only one thing. It's a 4. Okay, right here, though, what can I take to the fourth power and get 21? Well, there's two things. It's either positive or negative, the fourth root of 21. And then, let me get in the calculator. If you needed to know what that was. Oh, shucks. Did I leave it at home? Well, that's not good. I think I may have. Yikes. There you go. Oh, nope. I threw it down in my purse. Yay. Okay. So if I want to see what 3 plus the fourth root of 21 is, I typed it in wrong, dang it. That's about 5 and 1400ths if I want to do 3 minus the fourth root of 21. It's about 8600ths. Okay. This one, what do I take to the fourth power to get 24? Either positive or negative, whatever the fourth root of 24 is. Principal fourth root. I have a feeling I meant to make C 81. And I typed it wrong. So let's see what that is in decimal. So negative 3 plus the fourth root of 24. Negative 3 minus the fourth root. 24. And let's just see if it would have cleaned up though. 2, 12, 2, 6, 2, 3. Nope, I don't have 4 of anything. Okay, and then we got to remember some other stuff from years past. Remember, if you've got x to the fourth all cubed, remember that's an x to the 12th. Powers, multiply powers. So what they're trying to show you is like this thing is saying, what do I square and get plain old x? Well, whatever that is the square root of x, right? And if you did this with powers, to get that x, which is to the first, you'd have to put a half, because a half times 2 is 1. You multiply 2 reciprocals. Then you get a 1. So basically what it's getting at, that's a way to represent the principal square root, cube root, fourth root. And it's sort of like this. When you use these rational exponents, people mean them to be the principal root. So if you see a to the 1 over n, that's the nth root of a, the principal one. So if you've got 81 to the 1/2, that means the principal square root of 81. If you've got 8 to the 1/3, that means the cube root of 8. If you've got 16 to the 1/4, that's the principal fourth root of 16. Okay. And then don't forget about negative exponents way back in Algebra 1. Like when y'all saw x to the negative fifth, remember that was 1 over x to the fifth. It's just a definition. People are like, well, let's write a reciprocal as a negative exponent sometimes. Or if you start out in the bottom, x to the negative third, in the denominator, you pull at the top, it's x to the positive third. Okay? So if we use all this, then we can put the two together. And I'm just going to show you what it means. It's easier just to go to examples. This means the principal square root of 4 raised to the 5th power, because you can think of it as 4 to the 1/2 all to the 5th. Okay. Or it means take a 4 to the 5th and then find the principal square root of it, because you could also think of it this way, because either of those give you 4 to the 5 halves. Okay, personally, I like to think of it like this, because when you take the roots first, your number gets smaller instead of bigger, and it just boils down to whatever's in the numerator is the power, whatever's in the denominator is the root, and not just roots growing the ground. So you got find the principal square root of 4 and then raise it to the 5th. So principal square root of 4 to the 5th power, that's 32. Some of y'all are going to get to where you can do these in your head. Okay, and that's great. But I'm going to walk you through it if you can't. Like a negative exponent, though, means flip it to the denominator. And then that means let's do the principal square root and get a third. Okay, this one means take this principal square root of 16 and then cube it. Okay, this one means take that principal 8th root of 1 and raise it to the 7th. This one's what's the principal 4th root of 81, and let's cube it. So that's 3 cubed, that's 27. Okay, this one we're pulling it to the denominator, and then it means find the principal 5th root of 32 and then cube it. Okay, this one says write it in radical form and then approximate its value. So this is the 5th root of 9. And then if you approximate its value, you can type in the 5th root of 9, or you can type in 9 raised to the 1/5. But when you do, you have to put that in parentheses, because if you type in, if you type in 9 raised to the 1 divided by 5, it's going to do that first. And it's going to tell you 9/5, which is what? 1 4/5. We come up 1.8. We don't want that. So if you're approximating it, 9 raised to the 1/5, it's about 1.55. Okay, this is the principal 8th root of a 12 that gets cubed, or the principal 8th root of a 12 cubed. Okay, let's approximate it. 12 raised to the 3/8. It's about 2.54. Let's see. 12 cubed. What is 12 cubed? I guess I should probably make sure there's not 8 of something in there. Nope. 1, 2, 3, 4, 5. Got to 6. Didn't get to 8. Okay, so this is the principal 4th root of 7 to the 1st, and 7 raised to the 1/4, which you can type in 7 to the 0.25. It's about 1.63. This one's the 5th root of a 10 squared. And let's see, 2 50s, 50s, 2 25s. You don't have 5 of anything. So a 10 raised to the 2/5, which is, I'm just going to type in 10 to the 0.4. You get that. Okay.